Math 3 Lesson Summary Video. George W. Ferris's Day Off. This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this lesson is to use special right triangles, triangle trigonometry, and the symmetry of a circle to find the y-coordinates on a circular path. Carlos, Clarita, and their friends are celebrating the end of the school year at a local amusement park. Carlos has always been afraid of heights, and now his friends have talked him into taking a ride on the amusement park Ferris wheel. By asking the ride operator, he found out that this wheel has a radius of 25 feet, and its center is 30 feet above the ground. With this information, Carlos is trying to figure out how high he will be at different positions on the wheel. So Carlos is wanting to find out how far above the ground is he actually going to get. So the ride operator gave him some information and told him that the radius, so from the center of the wheel out to the outer edge, is 25 feet. And then he also knows that the height that the actual Ferris wheel, the center of the Ferris wheel, is off the ground is 30 feet. So we know that this center spinning part is 30 feet off of the ground, and we also know that the spokes on the wheel are 25 feet long. So if we're looking at, he wants to know what is the highest that he can get above the ground. So up here at the top of the wheel, so if this is 30 feet, and we know that the radius of the circle is 25 feet, so it would appear that the highest height up here at the very tip top would be 55 feet above the ground. And then at the bottom of the wheel, since this is 30 feet but this spoke is 25 feet, we're actually going to have to subtract 30 minus 25. So at the bottom of the wheel, he's still 5 feet off of the ground. And then when we go the furthest to the left and the furthest to the right, well, that's exactly even with the middle of the Ferris wheel, and we have already determined that that was at 30 feet. So we can use that information about the circle. We're just spinning around the circle. So we know the highest we're going to go is 55 feet, the lowest we're going to go is 5 feet, and when we're at the middle, we're at 30 feet. So pretty much everything between 5 feet and 55 feet, we're just going to keep going in a circle and kind of bouncing between 5 feet and 55 feet. Find the height of each of the points labeled A through J on the Ferris wheel diagram below. Represent your work on the diagram so it is apparent to others how you have calculated the height of each point. So if we're going to figure out heights, we're really trying to figure out how far it is from the ground. So we know that this is 30 feet. So that's why we know A is 30 feet off of the ground. So we've already found that one. We've already found F. It's got to be 30 feet off of the ground. So we found A and F's height fairly quickly. Unfortunately, our minimum and our maximum that we found on the other page, they don't actually fall on one of our points we're interested in. So that didn't help us very much. When we look at this picture, I don't really have anything to help me out shape-wise, but I know that right triangles are darn useful. So I'm going to try, this is the height, right? That's how high it is above the center anyway, this line A, and we know A is 30 feet. So if I can figure out this height, I can just add it to 30 feet, and that will tell me how high B is. So this gives me a right triangle, but I don't know this length because it's not the whole radius, and I don't know this length, but I do know this one. I know the hypotenuse. The hypotenuse is one of the radii, so it's got to be 25. And this makes me go back and start to think about how can I find measurements in a right triangle. And I know if I use trigonometry, I need to know one side and one angle, or I need to know two sides. So then I start thinking, I don't know any angles but the 90-degree angle, but I do know that this is a circle. And a circle has 360 degrees. And I also know that these are all evenly spaced, so if I just divide that 360 degrees up evenly, it should tell me what these angles are. So let's figure out how many angles there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 angles. So if I divide that 360 degrees up evenly into 10 angles, each angle should be 36 degrees. So now I know I have an angle that's 36 degrees. I know I have a hypotenuse that's 25, and I'm looking for this opposite side of the angle, because this is the opposite side. So if I'm doing opposite and hypotenuse, I remember that that's the sine of an angle. So the sine of an angle is equal to the opposite over the hypotenuse. So I know that my angle is 36 degrees. And I know that my hypotenuse is 25. And so I should be able to figure out what is that height going to be. I just need to multiply both sides by 25. So 25 times the sine of 36. When I type that in my calculator, I just want to make sure it's on degrees and not radians. And I get that this opposite side is about 14.7 feet. So if this piece right here, this height, is 14.7, well, I know it's got to be 14.7 above 30, so B must actually be at 44.7 feet. And so we can actually use trigonometry to help us find this triangle as well. It's going to have two 36-degree angles, so that angle is going to be 72. And then we still know that its hypotenuse is going to be 25. So we can do 25 times the sine of 72. And we can figure out that its height is supposed to be approximately 23.8 feet. And since, again, that's 23.8 above 30, that's going to be 53.8 feet. And that makes sense, because remember, when we figured out earlier that this very, very tip top is 55 feet, and that's getting really close. C is getting really close to being at the tip top. So that makes sense. So then I was like, well, I can just do triangles all the way around. But I started to notice some patterns and some things that I know about circles. Notice C and D. They're lined up. If I were to fold this circle in half along this line in the middle, this line of reflection, D and C are the same height. So if C is 53.8 feet above the ground, then D is 53.8 feet above the ground. And B and E, again, if we fold on that line of symmetry right down the middle and reflect it over, B reflects right over to E. So if B is 44.7 feet above the ground, then E is going to be 44.7 feet above the ground. And so symmetry is really going to help me kind of shortcut figuring out what some of these things are. I didn't have to do the trig all over again. I saw that those matched up. Well, then I start thinking about this line of symmetry, the AF line. If I were to fold the circle on the AF line, I notice that E and G line up and B and J line up. They're reflected across this horizontal line. So if this was 14.7 above 30 feet, this one's going to be 14.7 below 30 feet. And when I subtract 14.7 from 30, I actually get that J should be at 15.3 feet. And I can either do the same thing here and say, well, if this was 14.7, this one was 14.7. Or I can also notice that J lines up with G. So if J is 15.3 feet, G is 15.3 feet. And we get that symmetry going on there as well. D matches up with H, and C matches up with I. So if they were 23.8 above, these are going to be 23.8 below 30 feet, which makes them roughly 6.2 feet. And so just by doing a couple of triangles, just two of the triangles, using our trigonometry, we only had to do our trigonometry twice, we could line everything up with symmetry to figure out what everything else was equal to.